Good evening, everyone. So,
Good
in
evening, ma'am.
good evening, Bhumika. So, 12th syllabus இன்னைக்கு ஸ்டார்ட் பண்ணலாம். ஸோ நீங்கள் எல்லாருமே 12th பூமிகா நீங்கள் where are you from?
Ma'am, I am from Kanjipuram, ma'am. I am 11th, ma'am.
Okay, okay. How about Santosh? Where are you from?
Ma'am, Chennai 11th standard.
Okay, 11th standard. Vedant, you're from 12th standard, right?
Yes, madam.
Okay, fine. So basically today we'll be starting 12th syllabus. First, let us see what are the chapters there in 12th standard. First is solution. This is basically the chapter from volume 1. First is solution. Second chapter is electrochemistry, which is a very interesting one. Third chapter is chemical kinetics. Fourth chapter is D and F block. Fifth chapter is coordination compounds. So solution, electrochemistry, chemical kinetics. These three chapters are from physical chemistry. So where we can expect only numerical. D and F block and coordination compounds are from inorganic chemistry. And in volume 2, the first chapter is haloalkane, haloarene. Basically, in volume 2, we'll be having only organic chemistry. So the first chapter is haloalkane and haloarene. Second chapter is alcohol, phenol, and ether. Third chapter is aldehyde, ketone, and carboxylic acid. Fourth chapter is amine. So actually, these are all the chapters from NCRT. Here in NCRT, you will be studying it as amines. But if you are from state board, you will be studying it as organic compounds containing nitrogen. And fifth chapter is biomolecule. So these are all the 5 chapters from volume 2. So basically this is the 12th syllabus. So today we're going to start with electrochemistry, which is from physical chemistry. So basically in physical chemistry, as I've told you, you can expect only numerical. So before practicing numerical, you have to be very strong in your concept and you have to know how to apply those concepts. And finally, numerical part. So understanding concept and applying concept is very important. And final stage is practicing your numerical. Okay. So first, let us start with the concept part, and parallelly we'll be solving numerical also. Okay. I know there are few students from 11th standard, but don't worry. Anyways, we're going to start from the scratch. Anyway, I'm going to discuss fundamentals also, so you'll not have any problem, guys. Okay. If you have any problem, then please let me know. I'll clear that. Okay. Shall we start the session?
Yes, ma'am.
Okay. Marimuthu, you're 12th standard, right? Marimuthu? Kanna, you 12th தான Kanna?
Yes, ma'am.
Okay, fine. So, electrochemistry. So, Santosh and Marimuthu, have you studied this electrochemistry chapter in your school?
No, ma'am.
They didn't start it, right? Okay. How about Vedant? Santosh is from 11th standard. Okay, fine. How about
Ma'am, not
Vedant?
yet started, ma'am.
Okay, didn't start it. Fine. Fine.
Yes, madam.
So there is no difference between 11th and 12th. So everybody is fresh about this chapter. So no issues. Okay. Electrochemistry in this chapter basically we'll be studying about cells and batteries. See, in our day-to-day life, we are using cells and batteries, right? Basically, what is the basic application of cells and batteries in our regular life, where we are using it?
We are using the batteries for a device
Very
to
good.
let them start the flow of electrons from the positive terminal to negative terminal.
Very good. Very good.
Because I studied this and all in physics, madam, first lesson.
Okay, fine, fine. So basically, we'll be using cells and batteries in our most of the electronic devices. And what is the purpose of battery or cell? What is the purpose?
To produce potential difference.
Okay, what is the purpose of this difference in potential? What is the end result of this potential difference? You're there, but
Um,
I want the particular term. What is the
to
result
produce the
of
current.
difference? Sorry?
Current, ma'am, to produce a
Very
current.
good, very good. To produce current. So basically, we are using the cells and batteries in our regular life for current, right? For, we are using for electrical energy, right? Fine. So in this chapter, we're going to discuss how the cells and batteries are working. Okay. First of all, I'll tell you the chapter flow. Okay. In this chapter, first we'll be discussing two types of energies. One is electrical energy, another one is chemical energy. So first we'll see what is electrical energy, what is chemical energy, and flow of the chapter. Okay, then we'll get into the chapter in depth. So first we'll start with chemical energy. So in this chapter, we're going to see two types of energies. One is electrical energy, another one is chemical energy. Okay. First, we'll start with chemical energy. What is chemical energy? Kana 11th standard students also can try. Say, I'm not expecting any perfect answer and all. I want you to interact with me. That's it.
Okay, ma'am.
So, what is chemical energy? It is the energy involved during any chemical reaction. That's it. It is the energy involved in any chemical reaction. For example, I have a chemical species which is A. And in a chemical reaction, this chemical species is getting converted into B. So A is getting converted into B. It is a chemical reaction, right? For example, if this chemical component got a particular amount of energy, say 100 kilojoule of energy, and this B compound has a particular amount of energy, say 80 kilojoule of energy. In this process, A is getting converted into B. And how about the energy? Is it getting decreased or increased?
Decreased.
Decreased. So, how much unit of energy was released?
20 kilojoule.
Yes. So initially A got 100 kilojoule of energy, but now the product got only 80 kilojoule of energy, which means the remaining 20 kilojoule of energy was released. And here this 20 kilojoule of energy is the chemical energy involved in this reaction. So Vedant, how you told it is 20 kilojoule of energy?
Ma'am, by subtracting from the
Very
final value and initial value.
exactly. So here difference has to be represented with delta. And here the energy what I'm talking about is Gibbs free energy, which is called G, which is equal to energy of the final state minus energy of the initial state. Final state what I'm talking about is product. Initial state what I'm talking about is the reactant. So here final state is B and its energy is 80 kilojoule and minus 100 kilojoule. So what is the difference? It is minus 20 kilojoule. See here 20 kilojoule of energy was released, and here the minus sign represents that energy was released to the surrounding. Okay. See, whenever Let us say this is the system. Whenever we are supplying the energy to the system, then we have to represent with positive sign. Whenever the system is releasing energy, then the quantity has to be expressed with negative sign. Here, the energy is getting released, so that is why represented with negative sign. Okay. Here, the 20 kilojoule of energy is the amount of energy involved in this chemical reaction. Fine. Now, I have a reactant M, and this reactant M is getting converted into a product N. And here, the energy of this M is 80 kilojoules, and energy of N is 110 kilojoule. So, what is the energy difference here?
30.
Yes. So, it is plus 30 or minus 30.
Minus 30.
Is
Oh,
it
sorry.
minus 30?
Oh, sorry, ma'am. Plus 30.
Plus 30. So
Yes,
here
ma'am.
energy of the final state minus energy of the initial state. So energy of the final state is 110 minus energy of the initial state is 80 kilojoule. So here the difference is plus 30 kilojoule. So here in this process, a particular amount of energy was absorbed by the system. That is why we have a positive sign here. Okay. So whenever a chemical reaction is occurring, in some kind of chemical reaction, energy may release. In some kind of chemical reaction, energy may absorb. So the amount of energy basically involved in a chemical reaction is called chemical energy. And usually chemical energy is nothing but Gibbs free energy, which is delta G, or change in Gibbs free energy, which is delta G. Fine. Whenever we are talking about a chemical reaction, you would have heard about these terms: spontaneous reaction and non-spontaneous reaction. Basically, what is spontaneous and non-spontaneous reaction?
When the reaction occurs by itself, it is called spontaneous. Then the del G value should be negative for it.
Good, very good. So, if a chemical reaction is occurring by itself, we are not doing anything. The reactant will get converted into product by itself. Then that is called spontaneous reaction. It is basically a natural reaction. Non-spontaneous reaction is nothing but the chemical reaction which will not occur by itself. Now, here I have written two chemical reactions. According to Vedant, the first reaction is a spontaneous one. Right, Vedant? Right, Vedant. So you're telling me the first reaction is a spontaneous reaction because you told me for spontaneous reaction, the sign of delta G is negative,
Del G
right?
is negative.
So
Yes,
according
madam.
to your statement, the first reaction seems to be a spontaneous one, right?
Yes, madam.
But why for spontaneous reaction delta G has to be negative? Why
Um,
it shouldn't be positive? Can anyone guess the answer? My question is, according to Vedant, actually he's right. According to Vedant, for a spontaneous reaction, the sign of delta G has to be negative. And he is right. But I want the justification. Why it has to be negative? Yes, Santosh?
Because it lost some joules.
Very good. It lost some joules. But why it has to lose its energy?
Because it has to be react with itself, so no absorption.
Hmm. Okay. That was a good try, but that is not the exact answer, Santosh. But that was a good try. Kanna Marimuthu? Yes, Santosh. Fine. Sendam Shelby? Any guesses? Why for spontaneous reaction delta G has to be negative?
Ma'am, during natural reactions, the energy is morely released, ma'am.
Yes. Why it has to get released? Answer is perfect, but why it has to get released? Okay. See, in nature, Actually, we'll be talking about stability, right? In all natural processes, all the chemical species wants to be more stable. For example, see, we are a human being and we need comfort zone, right? Similarly, for every chemical species in this universe need a comfort zone. Technically, this comfort zone is called stability. uh, See how we can connect our comfort zone with, we can connect it with happiness, right? Where we are more happy, that is where we are so much comfortable, right? Here we are comparing our comfort zone with the happiness. Similarly, for chemical species, that has to be comfortable or that has to be stable. So here, chemical species comfort zone or chemical species stability is always related to its energy. Here, energy and stability are inversely proportional. If a chemical species got more energy, then that chemical species is highly unstable. Is that clear? Energy and stability were inversely proportional. What is mean by inversely proportional? What is inversely proportional?
When one system increases, another one will decrease.
Very good. If one parameter is increasing, then another parameter will get decreased. So that is called inversely proportional. If energy is getting increased, then it is getting least stable. Okay. So now let us come to this reaction. Here, A got 100 kilojoule of energy and B got 80 kilojoule of energy. So according to the value, we know that A got higher energy and B got lower energy. So according to this relationship, we know B got lesser energy. So B is more stable than A, right? So A itself is unstable and A got some opportunity to get converted into B, which is a more stable form. So definitely A will use its opportunity to get stabilized. So this is a natural process. Okay, that is why this reaction is a spontaneous reaction. So whenever you want to find whether the reaction is a natural process or a spontaneous process or a feasible reaction, then you have to find the value or you have to find the sign of this delta G. From this value only we calculated this delta G, right? So if delta G is negative, then that means a particular amount of energy was released. So the final product's energy was basically decreased and stability was increased. Okay. But contradictorily, in second reaction, the energy of M was less and energy of N was actually high. In fact, M was initially, it was more stable, and this M don't want to get converted into a product because which is a very less stable one. Okay, so this reaction will not occur itself. If we want to prepare this product, then we have to supply a particular amount of energy to prepare this product, and this kind of reaction is called non-spontaneous reaction. And for non-spontaneous reaction, delta G will be positive. And for spontaneous reaction, delta G will be negative. See, there are few 11th standard students, they'll be wondering what is Gibbs free energy. See, Gibbs free energy, you learn it in thermodynamics, which is 11th standard syllabus, okay? Now you would have not learned, but in future, definitely you'll be learning thermodynamics in your 11th standard itself. Fine. Okay, so now we understood what is chemical energy, right? It is the amount of energy involved in a chemical reaction. In some reaction, energy may released, and in some reaction, energy may absorb, right? So this is chemical energy. Now we'll talk about electrical energy. Okay, in your point of view, guys, what is electrical energy?
Ma'am,
Yes, Kanna.
today only I studied the electrical energy definition, ma'am. It is the
Yes.
product of power into time of usage.
Okay, right. Marimuta's answer was perfect. It is actually a simple one. Um, Marimuthu, can you please tell your answer? I've seen your chat, but can you please tell your answer, Kanma?
Moving of charge, ma'am.
Moving of charge. Okay, right. Vedant, your answer is also right, but it is a more technical form. But what I was expecting is a basic definition. Okay, actually, electrical energy is nothing but a current. That's it. Okay, electrical energy is nothing but a current. And what is current? According to Marimuthu, it is the flow of charged particle. Okay. Could you please tell me any charged particle you know?
Electron.
Very good, Santosh. Electron. Okay. See, movement of charged particle leads to a current. And according to Santosh, he told me electron is a charged particle. What is the charge of electron?
Negative.
Negative charge. So I have a particular quantity of or particular number of electrons, and if the electrons are moving in a particular direction, for example, so this is negatively charged electron. And if all the electrons are moving in a particular direction, then we'll end up with current. Okay. Now my question is, here electrons are moving from left to right. I've written like that only, right? From this arrow mark, I can understand that the electrons are moving from left to right. Because of this mobility of electron, we'll end up with current. And what is the direction of flow of current? You'd have learned in physics.
Opposite to the electrons.
Very good. So this is the direction of flow of electron, and because of this mobility of electron, we'll end up with current, but the direction of current will be in opposite direction. Why so? Why it has to be in opposite direction? According to Marimuthu, the definition is current is nothing but the mobility of or movement of charged particle. And here the charged particle is electron. And electrons are moving in a particular direction. Then current has to be produced in the same direction, right? But why it has to be in opposite direction? Actually, it is in opposite direction, but I'm asking for the justification.
Ma'am, when the circuit is connected in with the cell, the positive charges are moving from the positive terminal to negative terminal. So the electrons will move from the negative terminal to positive terminal.
Okay, right. So I can understand that electrons are negatively charged. So these negatively charged electrons are moving towards positively charged terminal, right? But you're telling me another parameter which is moving from opposite direction, right?
Yes, ma'am.
Okay. See, actually, mobility of electron and the current will move in an opposite direction. That is right, but we'll understand how it is actually happening. Now I'm going to explain this, but not with this electron and current, but with a different example, okay? See, I have a bowl full of ice cubes, okay? And into which I'm dipping a metal rod. And I'm holding this metal rod here. Initially, what I'll be feeling? At the initial stage, what I'll be feeling? I have an ice cube tub here, and here I have a metal rod, and I'm holding this metal rod here. Initially, what I'll be feeling? Nothing, right? But after 10 to 15 minutes, what I'll be feeling?
Chillness, ma'am.
Chillness. Why so? Very good. After 10 to 15 minutes, since it is a metallic bar, definitely I'll be feeling the chillness. But why?
Ma'am, due to the temperature in the hot uh, uh, temperature flows from the hotter body to cold body.
Yes, definitely.
So you will feel the chillness, ma'am.
Um, your statement is right. It is moving from higher temperature to lower temperature, but why I'm feeling the chillness?
Oh.
Here, which is the hotter object then?
Ma'am, the position where you are holding, ma'am.
Yes. Okay.
Because as compared to ice, that is more hot, ma'am.
Definitely, definitely. Okay. Anyone has to guess the answer? Vedant was partially right. How about Santosh, Sendamal Shelvan, Marimuthu, Bhumika? As I've told you already, I'm not expecting any perfect answer. I want you to interact with me, that's it. Or else class will be really boring. You just visualize what you're doing and tell me what you're feeling. Okay. So I'm going to hold this. Yes, Kanna, yes. Okay. I'm holding this metal bar. Initially, I'll not feel anything, but after 10 to 15 minutes, I'll be experiencing the chillness. So, actually, what we'll be visualizing is this chillness is moving from ice cube to my hand. That is what actually I'll be experiencing it. But actually, there is there is nothing called chillness in this universe. There is no cold in this universe. Actually, the place where heat energy is zero, there we'll be feeling the chillness. Okay, so there is a thing called heat, and there is nothing called cold in this universe. Okay, for example, there is a thing called light, but there is nothing called dark. If there is no light, then there is a darkness, that's it. So similarly, there is no cold or there is no chillness here. Only we have heat energy. Okay, where the heat energy is less, or where there is no heat energy, then we'll be feeling the chillness. But actually what we are experiencing is heat energy is moving from ice cube to hand, but actually it is not happening because there is nothing called chillness, right? But actually according to Vedant answer, what he is telling is heat energy is moving from higher temperature to lower temperature. Is he right? Is Vedant is right? See. Yes, Kanna, yes.
Yes, ma'am. Yes.
Yes. For example, I have a metal rod. This is end A and this is end B, and this end B I'm going to introduce into a candle. Okay, I'm going to hold this end. Okay, as we know, this end B will be really hotter because it is the candle part. Initially, I'll not feel anything, but as time goes on, heat energy will be moving from B to A, right? Because, for example, if we are heating this end, maybe temperature will be around 80 or 90 degrees Celsius. Here it will be initially 25 degrees Celsius, which is room temperature. So now, if you keep on heating, then heat energy will be moving from higher temperature to lower temperature. So that is why we are feeling the heat energy here. But here, in this example, this is around 25 degrees Celsius and this is around 0 degrees Celsius. Here, relatively, this is the higher temperature and this is the lower temperature. Actually, the heat energy from my hand is moving from this end to ice cube, right? So since my hand is losing the heat energy, I'm feeling the chillness. Okay, but what I'm really experiencing or what I'm visualizing is the impact of that. So actually what is happening, heat energy moving from my hand to the ice cube, but actually what I'm experiencing or what the impact is, uh, the chillness which is not even existing is moving from ice cube to the ice cube to my hand. See, actually this is happening, but the impact is this one, right? So the thing what is actually happening is in one direction and its impact is in other direction, right? This is what exactly happening in this mobility of electron case also. Actually what is happening is electron is moving from left side to right side, and the impact of mobility of current, impact of mobility of electron is the current which is actually happening in the opposite direction. See here in this example, originally the heat energy is actually exist and heat energy is moving from my hand to ice cube, but actually what I'm experiencing is, or what the actual impact is, ice cube's chillness is going from ice cube to hand, right? So it is an opposite direction. No, similarly the mobility of electron is in one direction and impact of this mobility is the current which is happening in the opposite direction, right? You're getting my point?
Yes, ma'am.
Fine. So that is why electrons direction or mobility of electrons direction and current direction will be in opposite direction. Fine. So we know electrical energy is nothing but current, and current is produced due to the mobility of charges, and here the charge is electron. Okay, this is right. And this kind of conductance is called metallic conductance. This you would have studied in physics. In physics, you'd have studied this current and electricity chapter, right? There we'll be studying this metallic conductance type. But not only electrons are charged particle, we have ions, right? What is ion? You know what is electron? It is basically a subatomic particle. But how about ions? What is
Uh,
ion?
Ma'am, initially, a substance will be in neutral state, ma'am.
Mm,
When positive charged particles gets released from the substance, it becomes negative ion.
very good, very good.
When electrons move away from the substance, it becomes positive ion. Like
Positive. Yes. Vedant answer is right, and Senthamil Shelvan's answer is also right. Senthamil Shelvan's answer is charged atoms. Right. See, we have to know the difference between atoms and ions. Basically, in atom, we'll be having three subatomic particles, right? Proton, neutron, and electron. Electrons are negatively charged and protons are positively charged, and there is no charge for neutron. And generally in atom, number of protons will be always equal to number of electrons. So basically number of positive charge is equal to number of negative charge. So atoms are generally neutral. But if number of proton is not equal to number of electron, then they are not called as atom, then they are called ion. Okay, and in ion we have two types of ions. If number of proton is greater than number of electron, then what will be the charge of that species? If number of
negative.
proton is greater, then the charge will be positive. Then positively charged ion is called cation. If number of proton is less than number of electron, then number of electrons are dominating here, so negative charge is dominating here, so the charge of the ion will be negative, and negatively charged ion is called anion. Okay, so of course cations and anions are charged species. Okay, not only these are ions, these were also ions, right? See here, sodium is losing its electron to form Na plus cation, and chlorine gained one extra electron to form anion. But this is not a single atom; it is a group of atoms. Still, this got some charge, right? So this is also considered to be an ion. So any chemical species with charge is called ions, right? So mobility of charged particle leads to current. So mobility of electron leads to current, and similarly mobility of ions also leads to current, right?
Yes,
Mobility
ma'am.
of, according to the definition, mobility of charged particle leads to current. So charged particle can be electron, or charged particle can be ions. So if the free electrons mobility leads to current, then that kind of conductance is called metallic conductance. This you would have learned in physics. Mobility of ions also leads to current, which is called electrolytic conductance, which we going to study in this electrochemistry chapter. So there is a difference between metallic conductance and electrolytic conductance. Basic, very basic definition is, or very basic differences. Here the current is produced due to flow of electrons, and here the current is produced due to flow of ions. That's it. So in this chapter completely we want to discuss this electrical conductance. Fine. Is that clear?
Yes, madam.
Okay. Uh, First, we'll see why this is called metallic conductance. First, we'll see the meaning of this metallic conductance and electrolytic conductance, and we'll get into the flow of the chapter. Why it is called as metallic conductance?
Ma'am, metals have a tendency to lose electrons, ma'am.
Yes, very good, very good. So, as far as metallic conductance are concerned, there the electricity is produced due to free electrons. Where these free electrons will be in metals, so that is why it is called as metallic conductance. Similarly, where these ions will be, for example, I have NaCl. NaCl is sodium chloride, which is a salt. I'm going to what will be the physical state of NaCl? I've
Solid, madam.
written there. Yes, it is solid basically. I'm going to dissolve this sodium chloride in water. So, of course, it will get dissolved, right? So, it will get dissociated into Na plus and Cl minus. If I'm dissolving the sodium chloride in water, so it will get Na plus, which is in aqueous medium, and Cl minus, which is also in aqueous medium. So, I have a beaker full of water into which I've dissolved this sodium chloride, and here I have a lot of Na plus and lot of Cl minus ion. See, this is a salt or this is a chemical compound, and I've dissolved this chemical compound in a water, and this got dissociated into cations and anions. So this kind of chemical compound is called electrolyte. Electrolyte is nothing but a chemical compound which get dissociated into ions inside the aqueous medium. Okay, so here NaCl is the best electrolyte, and similarly HCl. If we dissolve HCl in water, how it will get dissociated into?
H plus plus E.
H plus Cl minus. I have CH3COOH. What is the name of this compound? CH3COOH.
Acetic acid,
Acetic.
madam.
Very good, acetic acid. How it will get dissociated? CH3COO minus and H plus. I have sodium hydroxide. How it will get dissociated in aqueous medium?
Na plus plus OH, ma'am.
That's it. So all these chemical species are getting dissociated into ions inside aqueous medium. So that is why these chemical species are called electrolyte. And I've used this electrolyte to prepare the solution, which is called electrolytic solution. So these ions are present in this electrolytic solution. That is why it is called as electrolytic conductance. You getting my point? So free electrons are present in metals. That is why it is called metallic conductance. And ions are present in electrolytic solution. That is why it is called electrolytic conductance. Fine. You getting my point, Kana? Any doubt?
Yes, madam. No, madam.
Fine. So in this chapter, we want to discuss electrical energy, chemical energy, and we're going to see the relationship between these two energies. Okay, fine. Now we'll get into the chapter. Till now, we have seen the fundamentals. Okay. Now we're going to understand the term cell. Now, according to you guys, what is cell? What is cell?
Cathode, anode, and electrolyte, ma'am.
Very good, very good. So cathode, anode, and electrolyte. You're perfect. Okay. Any other answer? And basically, we'll be using the cell for our power as a power source, right? Fine. See, technically, cell is called as an electrochemical device. Actually, cell is a device where chemical reaction occurs. That's it. Okay, it is a device where chemical reaction occurs. Okay, in that cell, as Sendamal Shelvan, cell got a cathode, anode, electrolyte, and all that. But cell is actually, you visualize a cell as a device or any beaker or something. Okay, any device where chemical reaction is happening. So that beaker is called a cell. That's it. As simple as that. It is a device where chemical reaction is happening, which is called cell. And here we have two types of cells. How these cells are classified into two types is it is very easy. See, as I've told you already, there are two types of chemical reaction, right? What are they? What are the two types of chemical reaction which I've discussed earlier?
Ma'am, spontaneous and non-spontaneous.
Very good, very good. See, a cell is a device where chemical reaction is happening, and if that chemical reaction is a spontaneous reaction, then that is first category. If that reaction is a non-spontaneous one, then that is second category of cell. Okay. If the reaction is a spontaneous reaction, then that kind of cell is called electrochemical cell, or it is also called as galvanic cell, or it is also called as voltaic cell. Okay, if the chemical reaction happening in this device is a non-spontaneous reaction, then that kind of chemical reaction, that kind of cell is called electrolytic cell. Okay, if the chemical reaction is a spontaneous reaction, then what will be the sign of delta G?
Negative, ma'am.
Very good, it is negative. If it is a non-spontaneous one, then what will be the sign of delta G?
Positive, ma'am.
It is positive. Okay, fine. Since in electrochemical cell, the reaction happening is a spontaneous reaction, energy is getting liberated, right? Because in spontaneous reaction, see, this is spontaneous reaction, and here the energy was released, right? So in spontaneous reaction, the energy is releasing, right, which is called chemical energy, and this chemical energy will come out of the cell as a electrical energy. So in this kind of cell, chemical energy is getting converted into electrical energy. That is why we are using the cell for the power source. Okay, so we are using cells for the power source, as a power source, right? Because in that cell, which will be like a normal small cylinder, right, in which some chemical reaction is happening, and because of the chemical reaction, chemical energy is produced, and that chemical energy is released as the electrical energy, and which we are using in the electronic devices. Okay, you're getting my point?
Yes, madam.
So in electrochemical cell, chemical energy is getting converted into electrical energy. That's it. But in non-spontaneous reaction, reaction will not occur itself, right? So for the chemical reaction to occur, we have to supply a particular amount of energy. So in a beaker, I have a chemical reaction, and that chemical reaction is actually not happening. And for the chemical reaction to occur, I'm going to supply energy in the form of current. And that current is making the chemical reaction to occur. So in this kind of cell, electrical energy is getting converted into chemical energy. It is just the opposite. Okay, so there are two types of cell. One is electrochemical cell, another one is electrolytic cell. In electrochemical cell, the chemical reaction is a spontaneous reaction where delta G is negative, and where chemical energy is getting converted into electrical energy. And in electrolytic cell, it is a non-spontaneous reaction where electrical energy, which is a current, is getting converted into chemical energy. And in this chapter, 70% of the chapter is about electrochemical cell, and 30% of the chapter is about electrolytic cell. And definitely we can expect question from both the part. We cannot tell this is important, that is important, though the percentage of electrolytic cell is very less. Even though we can expect a question from electrolytic cell also. Okay, fine. So shall we proceed? Do you have any doubt? If you have
No,
doubt,
ma'am.
please ask me.
Yes, ma'am.
Um,
Right.
how
Right.
to find
Yes, Kush?
How to convert the electric energy into chemical energy?
I'll teach you. Okay, definitely we'll see the working principle of both the cells. Okay, there you'll understand how it is getting converted. Okay,
Okay,
that
ma'am.
was a very good curiosity. Fine, I'll teach you, Kanna. Definitely we'll see the working principle of both the cells.
Okay, ma'am.
Fine. So, first we'll be starting with the electrochemical cell. Later, we'll be discussing the second type, which is electrolytic cell. But before getting into this electrochemical cell, we have to understand another fundamental. See, I'm talking about a spontaneous reaction and a non-spontaneous reaction. But actually, what chemical reaction I'm discussing here or mentioning here is a redox reaction. In both the cells, it can be an electrochemical cell or an electrolytic cell. I'm talking about redox reaction. Okay, what is redox reaction? Have you guys heard about redox reaction?
Yes, ma'am.
Yes. What is redox reaction?
Both oxidation and reduction takes place simultaneously, ma'am.
Very good. What is oxidation? What is reduction? Because
Uh,
here we have few 11th standard students, right? For them, we have to teach them what is oxidation and reduction. According to your point of view, what is oxidation and reduction?
loss of electron is oxidation, ma'am.
Okay.
Then the gain of electron is reduction, ma'am.
Okay.
Or else addition of hydrogen is called as reduction, and the removal of hydrogen is called as oxidation.
Okay. Fine.
The oxidation number also varies, madam, from
Mm.
in the chemical reaction.
Okay, Kana. Okay. Fine. Your answer is right. Okay. For 11th standard students, we'll explain what is oxidation and reduction. Okay. Your answer is right, Vedant.
Yes, ma'am.
So first, we'll understand what is oxidation. For 11th standard students, if they are from state board, then definitely they would have learned this oxidation reduction because it is in their very first chapter. Am I right? Santosh, you're CBSE or a state board?
State board, ma'am.
So you would have studied oxidation and reduction in your 11th standard, right, Kana, in first chapter.
Yes, ma'am.
Okay. How about Bhumika? Bhumika? Fine.
Yes,
So
miss.
here, have you heard this oxidation reduction terms, Bhumika? Okay, fine. Let us discuss this. Sendama Chelvan's question is lithium ion battery is an electrochemical or it is an electrochemical cell. It's an electrochemical cell. Anyways, we'll be studying lithium ion batteries and all in the end of the chapter. So here, first let us understand what is oxidation. In a chemical reaction, if an element or a compound gains oxygen, then that is called oxidation. Okay, so the definition is addition of oxygen is called oxidation. Or we have another definition for oxidation, which is if a chemical compound got hydrogen and in a chemical process, if that hydrogen was removed, then that is called oxidation. So removal of hydrogen is also oxidation. For example, I have a carbon. Okay. To this carbon, I'm treating oxygen. And this carbon is reacting with oxygen to get converted into CO2. So here, carbon gained oxygen. So it is the addition of oxygen. And this process is called oxidation. Okay. Similarly, I have CH2 double bond CH2. Okay. Now this is getting converted into CH triple bond CH. Hydrogen from this carbon and hydrogen from this carbon was removed. So here the species lost its hydrogen, right? So this is also called as oxidation. Okay, this kind of reaction you would have studied in a reverse in a reversal way, right, where ethene is getting converted to ethine is getting converted to ethene. You would have studied in your organic chemistry, but basically I've taken this example to explain how this oxidation is actually happening there. Okay, fine. So, in terms of oxygen and hydrogen, this is the definition. In a chemical reaction, if some species is gaining oxygen, then that is called oxidation. Or in a chemical reaction, if hydrogen is lost or if the hydrogen was removed, then that is also called as oxidation. This is in terms of oxygen and hydrogen. This you will be studying in organic chemistry. But as far as physical chemistry is concerned, the definition of oxidation can be explained in terms of electron also. In a chemical reaction, if a chemical species is losing its electron, loss of electron is also called as oxidation. For example, I have sodium, and a sodium stable, a sodium acid stable. What is the electronic configuration of sodium, or what is the atomic number of sodium, first of all?
Hmm? What, ma'am?
Atomic number of sodium, and what is the electronic configuration of sodium, and how about its stability?
Atomic number is 11, ma'am.
Okay.
Yes, ma'am. Then when it loses one electron, it becomes stable, ma'am. 2,
Yes.
8 configuration.
Yes. So the original electronic configuration is 1s2, 2s2, 2p6, 3s1. This is the exact electronic configuration of sodium. And this is the last shell where electrons are filled. So this is the valency shell. And this valency shell, sodium got only one electron. According to the principle, uh, in an atom, the outermost shell should have 8 electron to attain stability. This is called octet rule. But according to sodium, this got only one electron in the valency shell, which is the outermost shell. So the sodium has to gain 7 more electron to complete its octet. But any atom cannot gain 7 electrons. So sodium will lose this one electron, and this becomes the valency shell. This one electron was lost, then this will be the valency shell, right? And second cell is the valency shell, where we have 8 electron and the octet was achieved. So sodium as such is unstable because it didn't complete its octet. So sodium has to lose its electron to attain stability. So in this process, sodium is losing electron. So here it is the loss of electron, and this reaction is called oxidation. Fine, you're getting my point.
Yes, madam.
Similarly, reduction is just the opposite of oxidation. Here in oxidation, addition of oxygen and removal of hydrogen, but in reduction, addition of hydrogen and removal of oxygen. Then how about electron? How about electron?
Gain of electron, ma'am.
Yes, gain of electron. It is just the opposite of oxidation. Okay. Here, let us take chlorine. Atomic number of chlorine is 17 and its electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p5. Which is the valency shell? For chlorine, which is the valency shell? Which is the valency shell?
3p, ma'am.
Aha. 3s and 3p. See, 3p is the valency subshell. Okay, so third shell is the valency shell, where we have S and P were subshells. Okay, so whenever I'm talking about valency shell, you have to tell me both 3s and 3p. Whenever we are talking about the valency shell, check for the principal quantum number here. The highest principal quantum number is the last shell or the valency shell. Okay, here third shell is the valency shell, and you have to definitely include S also. So in third shell we have 7 electrons. Of course, chlorine didn't complete its octet because it is unstable. So to attain stability, Chlorine has to gain one electron. Gaining one electron is very easy. So chlorine will gain one electron from any other species. So chlorine will gain one electron to get converted into Cl minus. Why I'm writing the negative sign there and why I've written positive sign here?
While the electrons is lost, it becomes positive. The neutrality is lost.
Very good. So as far as sodium is concerned, number of proton is 11 because atomic number is 11, and electron is also 11 because in atom number of protons and electrons will be same. But now sodium lost its electron, but proton was still 11, but electron was 10. So positive 11 and negative 10, it is totally plus 1. That is why I've written plus 1 charge on sodium. As far as chlorine is concerned, atomic number of chlorine is 17. So proton count is 17 and electron count is also 17. Basically, it was neutral. Now it gained one electron. Still the proton count is 17, but electron count is 18. So it is plus 17 and minus 18. It is minus 1. This is the total charge on chlorine now. Now chlorine gained one electron, so this reaction is called reduction. Okay, fine. So in a chemical reaction, if a chemical species lost its electron, then that is called oxidation. In a chemical reaction, a chemical species gained electron, then that is called reduction. So whenever a chemical reaction is given, we have to identify whether the chemical reaction is an oxidation reaction or a reduction reaction. I'll give you an example. I want you to find whether the reaction is an oxidation or reduction. Could you please tell me whether this reaction is an oxidation or reduction?
Oxidation, ma'am.
Oxidation. How?
Due to loss of electrons, ma'am.
Okay. Have you found the electron was lost there?
Because of increase in positive charge, ma'am.
Yes. See, here iron got 2 positive charge, but in the end product, iron got 3 positive charge, which means positive charge is increased or one negative charge was decreased. So negative charge is nothing but the electron. So electron was decreased is there. So it is basically loss of electron. So it is called oxidation. Here, without thinking about electrons and all, just by seeing this number itself, we can find whether it is an oxidation reaction or reduction reaction. See, this number is called oxidation number. It is oxidation number or oxidation state. In a chemical reaction, oxidation number is increased, then that is called oxidation. If the oxidation number is decreased, then that is called reduction. Okay, you're getting my point. If the oxidation number is getting increased, it is increased from 2 plus to 3 plus, so it is oxidation. If the number is decreasing, if the oxidation state is decreasing, then that is called reduction. Okay, as simple as that. Fine. Guys, do you have any doubt till now?
No, ma'am. All clear, ma'am.
Fine. I'll write you a chemical reaction. Okay. Now A and B are reacting together. Now A is getting converted into A2 plus and B is getting converted into B2 minus, right? According to A, what is actually happening to A?
Two electrons lost.
Yes. So initially the oxidation state of A was 0 and now it is 2 plus. So oxidation number is getting increased. So basically this is oxidation. And what is happening to B? Oxidation number is decreased, right? So initially it was 0, now it is minus 2. So the oxidation number is decreased. So this is reduction. So here in one chemical reaction itself, both oxidation and reduction is happening, right? So this kind of chemical reaction is called redox reaction. Redox reaction. Okay, fine. So here we understood what is oxidation, what is reduction, what is oxidation number, and from oxidation number how to find whether the species is getting oxidized or reduced. And now we're going to understand two more terms. Okay, we're going to understand what is oxidizing agent and reducing agent. So first of all, what is agent?
Helps in the reaction. The
Yes,
substance which helps.
agent is someone who is supportive for a process to occur, for any process to occur, right? So agent is someone who is responsible for the chemical for any process to occur is called agent. Oxidizing agent is the thing, or oxidizing agent is the chemical species which is responsible for the oxidation to occur. According to this example, we know this A lost its electron. So A was oxidized. A lost its electron. But who is responsible for this oxidation? B. Because A lost its electron, the electron lost by A was gained by B. Without B, A cannot get oxidized, right? So A was oxidized, and the species which is responsible for this oxidation is B, right? So B is called as an oxidizing agent. You're getting my point. So oxidizing agent will reduce itself and it will helpful in oxidizing some other species. And similarly, what is happening to B? B is getting reduced. How it is getting reduced? Because B gained electron, but who gave their electron? A. And A was responsible for the B to get reduced, right? So A is called as an as a reducing agent. So reducing agent will oxidize itself and it will helpful in reducing some other species. You're getting my point?
Yes, ma'am.
Fine. So oxidizing agent is the agent or the chemical species which is responsible for the oxidation to occur and it will reduce itself. And reducing agent is the chemical species which is responsible for the reduction to occur and it will oxidize itself. Okay, that's it. So whenever in this electrochemistry, the chemical reaction, what I'm talking about will be always a redox reaction. It can be a spontaneous one or it can be a non-spontaneous one, but definitely it will be a redox reaction. Okay. And this fundamental you would have studied in your 11th standard itself. If you are a CBSE student, there is a separate chapter called redox reaction in your 11th standard. If you are a state board student, it will be in your first chapter in basic concepts of chemistry. Fine. Now we got few understanding about this redox reaction thing. And in this redox reaction, we have different types of redox reaction. And here the oxidation state is very clear, right? The oxidation state of A is 0 and B is 0. In the product, the oxidation state of A is 2 plus and B is 2 minus. But in all the time, they'll not give you this proper oxidation state itself. They'll give you as a compound and we'll be in a situation to find the oxidation state. For example, the classic example is this one. Um, see, I've written a chemical reaction where MnO4 minus is getting converted into MnO2. I want you to tell me whether this reaction is an oxidation reaction or a reduction reaction. And I want the justification also.
Oxidation reaction.
Okay, can you please Vedant?
Ma'am?
Justification, Kanna?
Ma'am, because the oxidation number gets increased from positive
Ah,
to
see,
negative to positive.
initially, here in this case, I had only Fe. So the oxidation state here I've written is only for Fe. And it was increased and it was very clear it is oxidation. Here, I have both manganese and oxygen. So this -1 is not only applicable for manganese or for oxygen, it is applicable for both MnO4. So you have to find the oxidation state of manganese particularly in both the case. Any other answer? Santosh, Bhumika, Sendamichelvan, Marimuthu.
Ma'am,
Mm.
Ma'am, the oxidation state of oxygen is -2 only, ma'am.
Yes, it is -2.
Ma'am, then MnO2 means there will be 4 electrons, 2 into -2, that is -4.
Mm.
Then here in the LHS we have O4 minus, ma'am.
Mm.
Then they are same only, ma'am. LHS and RHS.
Okay, fine. Let us understand here. Here, the central atom is manganese and the terminal atom is oxygen. Whenever a chemical reaction is given, first of all, we have to find which is getting oxidized and which is getting reduced. Here, in both the side, oxygen will have a -2 charge. So, oxygen neither oxidized nor reduced. Now, we have to check for the manganese. Now, I'll teach you how to find the oxidation state of this combined form. Okay. How many manganese I have here? How many manganese I have here?
Ma'am.
In MnO4 minus, I have only one manganese, and the oxidation state of manganese to be calculated. So I'm taking it as X, and I have 4 oxygen, and the oxidation state of oxygen is -2. See, generally for oxides, the oxidation state is -2. Okay. For peroxide, the oxidation state is -1. Here it is just the oxide, so it is -2. And I have no more species here. So which is equal to total charge on this complex is -1, or the compound is -1. So I have to write it in the right side. So 1 into x is x, plus into minus is minus, 4 into 2 is 8, which is equal to -1. So what will be the value of x here?
It's 7, ma'am.
+7, right? Similarly, could you please calculate the oxidation state of manganese? In MnO2. In MnO2, I want you guys to calculate the oxidation state of manganese.
+4, ma'am.
Yes, it is +4 because I have only one manganese and oxidation state of manganese to be calculated. I have 2 oxygen and oxidation state of oxygen is -2, which is equal to, I have no charge on the top. So it is equal to 0. So x -4, which is equal to 0. So x is equal to +4. So the oxidation state was +7 to +4. So whether it is oxidation or reduction,
Ma'am, reduction, ma'am.
yes. So here the oxidation state of manganese was -7, and it is, I mean, a +7 and it is +4. Here the oxidation number is getting decreased. So this is reduction. So this is how it works. Now I'll give you another chemical reaction and I want you to find whether the reaction is an oxidation reaction or the reduction one. MnO4, MnO4 2 minus to MnO4 minus. Could you please tell me whether this is oxidation or reduction?
Oxidation.
Okay, Marimuthu's answer and Vedant answer is oxidation. Anyone, either Marimuthu or Vedant, anyone, can you please justify your answer?
Shall I justify, ma'am?
Ma'am, MnO4 to minus is change into MnO4 minus, ma'am.
Okay. Have you found that is oxidation reaction?
Gaining power, charge of the oxygen, ma'am.
No. See, if it is a group of atoms, then you have to find the oxidation state of particular species, right?
Ma'am,
Uh,
ma'am, I took the value of m as x minus 8 is equal to minus 2.
mm,
When x is equal to 6, ma'am, I got for the left hand side, ma'am. Then I
mm,
got x is equal to 7 in right hand side, ma'am.
mm.
So it is proved that the oxidation number increases. So
Yes.
therefore, it is oxidation.
Very good. That's it.
Yes,
So, whenever the species is a group of atoms, then you have to find the oxidation state of each species. Okay.
ma'am. But here we can directly say no, ma'am. MnO4, MnO4. We cannot do like that, ma'am.
No, Kana, always it will be misleading. Okay. Whenever a reaction is given and whether you have to find whether there is oxidation reduction, definitely you have to find the oxidation state of that chemical species and you have to justify.
Yes, ma'am.
If you see the reaction, you cannot find and it will be definitely misleading.
Yes, ma'am.
So here, the oxidation state of manganese is +6. So how to calculate this? I have only one manganese. Oxidation state of manganese is X. I have four oxygen. Oxygen's oxidation state is -2, which is equal to -2. So X minus 8, which is equal to -2. X is equal to +6. And similarly, the oxidation state of manganese and MnO4 minus is +7. So 6 to 7, the oxidation number is increasing. So it is oxidation. Fine. One more example, okay? Cr2O72 minus to chromium 3 plus. Now we have to find whether this reaction is oxidation or reduction.
Reduction, ma'am.
Justification. Can you please justify your answer?
Me, ma'am.
Yes, Kanna, yes. Or if
Yes.
anyone has to try this, please try. If anyone couldn't, then Vedant, please justify your answer. Santosh, can you please try at your end? Kanna, can you please tell me whether this reaction is oxidation or reduction? Take your time. Please don't give up. Please take your time. In left side, we have Cr2O72 minus, right? Find the oxidation state of chromium.
Yes,
Find the
ma'am.
oxidation state of chromium.
Minus.
It will not be minus. It will not be minus, Kana. See, for which you have to find the oxidation state. For which species you have to find the oxidation state?
Chromium.
Chromium. So, how many chromium you have?
2 chrome.
So, 2 chromium and oxidation state of chromium, we don't know. I'm going to take it as X. X, the chemical species is oxygen. How many oxygen we have?
7
7. And what is the oxidation state of oxygen? I've told you
minus 2
minus 2. Minus 2. So that's it, right? We have no other species. So which is equal to what is the total charge on the system? On Cr2O7, what is the total charge?
minus 2
Very good. So now simplify this and find the value of X.
plus 6 ma'am.
It is plus 6. Right side we have only one chromium, we have no other chemical species, and the charge on chromium is plus 3. So chromium's oxidation state was changed from plus 6 to plus 3. Now the oxidation number is getting decreased, so this reaction is reduction reaction. That's it. Okay, so Vedant answer was right. Your answer was reduction, right, Kana?
Yes, ma'am.
Fine. Okay, I'll give you a question. I want you guys to solve this. Here is the question. There is a chemical reaction and we have 4 options and we have to find the right option. Take your time. Apply the concept what we have studied till now and tell me your answer. So the options are lithium undergoes reduction, lithium undergoes oxidation, nitrogen undergoes oxidation, or lithium is a oxidant. Oxidant is nothing but oxidizing agent. Reductant is nothing but reducing agent. That's it. So find the oxidation state of each chemical species. Find the oxidation state of lithium, nitrogen, and the product, find the oxidation state of lithium and nitrogen. Okay. If you want clue, please let me know. I'll give you a clue.
Yes, ma'am. Give me.
Okay. See, here the species in a natural state, right? Here I have only one lithium and there is no charge. So what will be the charge over there? Then if there is no charge, so what will be the number or oxidation state?
0.
0. In N2, though it is a molecule, we have no charge over there. So here the oxidation state of nitrogen is also 0. in this lithium nitride, you have to find the oxidation state of both lithium and nitrogen. See, this is a compound, and the total charge was zero, but each lithium and nitrogen got its charge. How to find that? Either you have to know the oxidation state of lithium or you have to know the oxidation state of nitrogen, right? See, where this lithium in the periodic table?
Alkali metals, ma'am.
Alkali metals, very good. So, could you please tell me the other alkali metals? Lithium, sodium,
Sodium, potassium, rubidium,
potassium,
cesium, francium.
rubidium, cesium, francium. All these were group 1 element and they are called alkali metal. And generally, alkali metals oxidation state will be +1. Because just now we have discussed about sodium and the oxidation state of sodium was 11 and the electronic configuration is 1s2, 2s2, 2p6 and 3s2. So the valency, I mean 3s1. So valency shell got only one electron, and to complete its octet, sodium has to lose its one electron. Similarly, I mean, or this is the same case for rest of the elements also. For example, in lithium, the atomic number of lithium is 3, and the electronic configuration is 1s2, 2s1. So this is the outermost shell, and this outermost shell got only one electron, which is unstable. So this has to lose its one electron to attain the stability or to attain the inert gas configuration, which is helium's configuration. So though it is lithium or sodium or rest of the species in group 1, all the elements will lose its one electron to attain the stability. So for all the elements in group 1 will have a +1 charge. Similarly, for group 2 element, the charge will be, or the oxidation state will be
+2, ma'am.
+2. See, the elements are
Alkaline
elements which are
+2.
present in group 2. Beryllium, magnesium, calcium, strontium, barium, radium. All the elements stable oxidation state is +2. See, let us take for calcium. What is the atomic number of calcium?
Right. Um,
20.
yes,
So electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. So which is the valency shell for calcium?
4s.
Yes. So fourth shell is the valency shell, and here we have only 2 electrons. Again, it doesn't complete its octet, so it has to gain 6 more electrons, which is highly impossible. So this calcium will lose its 2 electron to complete the octet or to attain the noble gas configuration. So since calcium will lose its electron, the oxidation state will be 2 plus. So not only for calcium, for all the elements in group 2, the stable oxidation state is 2 plus. Okay. So here we know the oxidation state of lithium as +1. And now tell me what will be the oxidation state for nitrogen. Same way, uh,
-1.
minus, it is
1,
not
ma'am.
-1 because we have 3 lithium. So it is
Then
Li3n.
-3, ma'am.
-3. So oxidation state of lithium is +1 and the oxidation state of nitrogen is -3. So now tell me what is happening.
-2. Reduction.
Okay, lithium from zero oxidation state, it is getting converted into +1 oxidation state. Nitrogen from zero oxidation state, it is getting converted into 3 minus oxidation state. So, which is getting oxidized and which is getting reduced?
Lithium oxidized, nitrogen reduced.
Yes. So, could you please tell me the right option?
Lithium undergoes oxidation.
Yes, lithium undergoes oxidation. First option is lithium undergoes reduction, but actually it is getting oxidized. So this is ruled out. And nitrogen is getting reduced, and here it is given as oxidation. This is also wrong. If a chemical species is getting oxidized, then that will be a best reducing agent. But here lithium is given as an oxidant, which is again a wrong statement. Okay. So here second option is right. You're getting my point?
Yes, ma'am.
Okay. I'll give you an activity and I want you to find whether that chemical reaction is a oxidation reaction or reduction reaction. And I want you guys to try. That's it. Okay. And in next class, I'll explain you that reaction. See, mm, 2 times of Br minus is getting converted into Br, and I want you to find whether this reaction is a oxidation reaction or reduction reaction. Okay.
Oxidation, ma'am.
Okay, oxidation. How send them, children?
Loss of electron, ma'am.
Right. How you found the electron was lost?
Due to the charge.
Okay. Initially it was Br minus, and here it is getting converted into 0. So -1 to 0. So you're telling me the negative charge is decreased and loss of electrons, so it is oxidation. Your answer is right. But could you please tell me how many electrons were lost in that reaction? If it is Fe2 plus to Fe3 plus, and it is very clear only one electron was lost, right? But in this reaction, I want you to tell how many electrons was lost.
2 electrons, ma'am.
Okay, how?
Because there are 2 Br minus, ma'am.
Yes, right, Kanna, right. See, let us clearly understand the difference between Br and Br minus. What is the valence electron of bromine? What is the valence electron of bromine? In valence shell, how many electrons will be there in bromine? It is in 17th group. Okay, fine. So, which means you have to know from the group number, you have to find the valence electrons. Okay. In next class, I'll teach you how to find the valence electron from group number, and I'll teach you I'll teach you how those electrons are lost. Okay, and Sendamil Children's answer was right. Here we have 2 times of Br minus, and that extra electron was lost from each Br minus, and his answer is right. But without knowing the valence electron of bromine, we cannot find how these 2 electrons was lost. But I know why you're hesitating, because you don't know the atomic number of bromine, right? If you know the atomic number, definitely you'll write the electronic configuration to find the valence electron. But without even knowing the atomic number, just by seeing the position of the chemical species in the periodic table, we can easily find the valence shell, valence electron, and its combining capacity also. In next class, first I'll teach you that, and we'll get into this reaction. And his answer was perfect. 2 electron was lost, and that reaction is the oxidation reaction. Okay. And after discussing this reaction, we'll be getting into the chapter where we'll be studying the electrochemical cell, where we'll be discussing the working principle, and finally we'll solve numerical also. Okay. If you have any doubt, please ask me, or we'll wind up the session. Yes, Vedant?
Ma'am, nothing, ma'am.
Okay, Kanna. Thank you, sir. Thank you. Bye, guys. Bye. Good night.
Ma'am, thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.